Hello guys, and welcome to Safer Soccer Academy the Intellect on YouTube. In this channel, we are out to help the advanced level science students to attain their academic excellence and their academic goals by providing them with the correct and the time-saving approach to all GCE questions as proposed by the GCE board, and we perform that function in all the science subjects, all the advanced level science subjects, because we are a team of teachers that can perform that function best. So in this video, we are looking at June 2021 Advanced Level Physics Paper 2, Section 1, Question 1. Okay, the question reads, the A part of the question reads, the force per unit length F between two current carrying conductors kept a distance A apart in the vacuum is suggested by an engineering physicist to be given by F, which is equals to mu naught I1 I2 over 2A, where mu naught is the permeability of a vacuum. I1 and I2 are the currents in the conductor. Determine whether the equation is homogeneous or not. B is state with the aid of an example why an equation can be homogeneous but incorrect. So we dive in directly to the solution of our question. The A part of the question, determining whether or not the equation is homogeneous. Okay, we know that homogeneity, an equation is said to be homogeneous when the base units on both sides are equal. In some books, you will see when the additive terms on both sides are equal, but no matter the definition, in this case, we are concerned with the practical work. That is, we know that the base units on both sides need to be equal. So to prove that the equation is homogeneous, to prove whether or not it is homogeneous, then we need to find their base unit first and compare them. If they are the same, then it is homogeneous. If they are not the same, then the equation is not homogeneous. Okay, so let's find for the base units of the left hand side. We know that from F, which is equals to force per unit length, because many students had confused it, that F there was not the force only, it is force per unit length. It was well enumerated in the question. So let's find the unit of the left hand side. The unit of the left hand side here will be kilogram per second squared, because we know that force, the unit of force is kilogram meters per second squared. Then now per length, per unit length, which is meter. So we see that meter will cancel meter. So we have here kilogram per second squared. The unit of the left hand side is kilogram per meters per second squared. So now let's find out the units of the right hand side. Finding the unit of the right hand side, we know that the force, the equation was force is equals to mu naught I1 I2 over 2A. So we should find the units of I1 I2. The unit of I1 times I2 is simply A squared, because we know that I is the current and the unit of current is ampere. Ampere times ampere is ampere squared. The unit of A is M. Now there is no 2 because we know that 2 is said to be dimensionless. Now let's now find the unit of mu naught. We know that C squared is equals to 1 over mu naught times epsilon naught, which just implies that mu naught is equals to 1 over C squared times epsilon naught, where C squared is simply the speed of light in the vacuum, mu naught is the permeability of the vacuum like we said in the question, and epsilon naught is the permittivity of free space. So we should find first of all the units of epsilon naught, from which we can take it from the Coulomb's law. We know that from the Coulomb's law, F is equals to K Q1 Q2 over R squared, but K, which is the Coulomb constant, is 1 all over 4 pi epsilon naught. So we imply that our force will be Q1 Q2 all over 4 pi epsilon naught times R squared. So we imply that our epsilon naught will be Q1 Q2 on 4 pi times FR squared. Now we want to find the unit of epsilon naught in order to find the unit of mu naught. But now, seeing that when we write units of Q1, Q2, units of FR squared, you waste a lot of time. So let's go directly with dimensions. So the dimensions of epsilon naught will be Q1, the dimension of Q1, Q2 over the dimension of F times the dimension of R squared. There is no need writing the dimension of 4 pi because you know that 4 pi is said to be dimensionless. Now, Q is simply the quantity of charge, and the quantity of charge, the formula is given by current times time, and the unit is given by AS. So we know that the unit is given by AS means that the dimension is given by IT, which the dimension of current is capital I and the dimension of time is capital T. So it means that our epsilon naught will be I squared times T squared, because we have Q1 times Q2, so their unit will be squared, of course, all over F, which is MLT to the power negative 2 times R squared, which is L squared. We know that the dimensions for meters or for the distance is L. Now the dimension, we know that force has base unit kilogram meters per second squared. So it means that the dimension of the mass there is simply m, the dimension of the distance is L, the dimension of time is t, so we have t negative 2. Okay, now simplifying our expression, we see that L times L is L cube. When t squared will go up, it becomes t squared times t squared, which is t to the 4. So it means that our expression simplified will have m to the negative 1, that is per, that is we have m to the negative 1, of course, times L to the negative 3 times t to the 4 times I squared. Okay, now we now find the units of epsilon naught, of which m is the dimension of kilograms. M is the dimension of the mass, of which the mass has unit as kilogram. So we have here per kilogram per meters cube second to the 4 times ampere squared. So this is the unit of epsilon naught. Now finding the unit, how we find the units of epsilon naught, you can now find the units of mu naught, of which the units of mu naught will be 1 all over the units of c squared is, we know that c is the speed of light, so it is meters per second. Now all squared will be meters per second squared times this unit of epsilon naught that we have found here, which is per kilogram per meter cube second to the 4 times ampere squared. Okay, simplifying our expression, we see that we have here meter squared times per meter cube. Following the laws of indices, we maintain the base and add their powers. Adding their powers, we have 2 minus 3, which is negative 1. Now we see what again, we have s to the negative 4 times s to the negative 2 times s to the 4. See, applying the laws of indices, maintaining the base and adding their powers, we have s to the 2. Okay, so now our simplified expression of mu naught will be kilogram meters per second squared per ampere squared, because we know that k negative 1, when it goes up, it becomes kg normally, and m negative 1, when it goes up, becomes m. S2, when it goes up, it becomes s negative 2, and here we have a2, when it goes up, it becomes a negative 2. Okay, so this is the unit of mu naught. Now we are not asked to find the unit of mu naught, we are asked to find, we're supposed to find the unit of the right hand side. Okay, so the unit of the right hand side directly will be the unit of mu naught, which is kilogram meters per second squared per ampere squared times ampere squared all over meters, which will simply give us kilogram per second squared. Okay, now we know that what here we have meters cancel meters, and per ampere squared will cancel ampere squared, of course, so we'll be left with kilogram per second squared. Okay, so we see that the unit of the left hand side is kilogram per second squared, and the unit of the right hand side is kilogram per meter squared. So we see that their units are equal. It means that we can conclude that our equation is homogeneous. So since the unit of the left hand side is equal to the unit of the right hand side, which is equal to this, then our equation is said to be homogeneous. Okay, let's go to the B part of the question. Why an equation can be homogeneous but not correct? The first thing is that we know that an equation, or we know that homogeneity is not a true test for correctness. Homogeneity is not a true test for correctness due to several reasons. So we'll just enumerate 2 reasons here. So an equation can be homogeneous but not correct due to the absence of the correct dimensionless constant or the presence of the wrong dimensionless constant. So we'll go to the examples. We have force is equal to 3ma, which is homogeneous but not correct because of the presence of a wrong dimensionless constant. This 3 here is the wrong dimensionless constant. We know that the force has formula F is equal to ma. There is no 3, so there is the presence of a wrong dimensionless constant. It means that the equation is wrong, is not correct, but it's homogeneous. Now Ke, which is the kinetic energy, is mass times velocity squared, which is homogeneous but not correct due to the absence of the correct dimensionless constant. The correct dimensionless constant is simply half, but the equation is homogeneous but it is not correct. So that is we retain that homogeneity is not the true test for correctness. So these are 2 examples that we gave. The question needed 1, but I gave 2 so that it should better your understanding. So guys, we have come to the end of this video, and if the video is interested to you, I'll invite you to like, share, and subscribe to the channel. Subscribing to the channel, when you subscribe to the channel, you activate the notification bell so that you should be notified to all our videos that will be uploading. You should be one of the first to be notified to all our videos that will be uploading. So not forgetting that in science, Consistency is the key.